Let's look at part E. I have negative 3 to the power 4. That means that I'm going to multiply negative 3 times itself 4 times. That gives me negative 3 times negative 3, which is 9, times negative 3 times negative 3. 9 times negative 3 is negative 27 times negative 3, and that's going to give me 81. Now, how is F different than part E? The difference here is the parentheses. So these parentheses were saying that it was negative 3 to the power 4. Here, I want the negative of 3 to the power 4. So I want negative of 3 to the power 4, which is the negative of 3 times itself 4 times, which is negative 81. We can talk about ordering integers. So we're going to define a to be less than b if there's some positive integer k such that a plus k equals b. A is less than b if and only if, when I subtract b minus a, I get a positive integer. That is, b minus a is greater than 0. So here are some properties of inequalities of integers. If I have x is less than y and n is any integer, then I can add n to x and y, and the inequality is preserved. So x plus n is less than y plus n. If x is less than y, then if I look at their negatives, negative x is going to be greater than negative y. If x is less than y and n is positive, then I can multiply both sides of my inequality and the inequality is preserved, so nx is less than ny. On the other hand, if n is negative and I multiply on both sides of my inequality, the inequality flips so that nx is greater than ny. So let's try applying those properties to solve some inequalities. So I want to find all integers x that satisfy the equation or the inequality x plus 7 is less than negative 5. Well, I can add negative 7 to both sides of my inequality, and that's going to preserve the inequality. So I'm going to have x on the left and negative 12 on the right, so x is less than negative 12. In part B, we can start off similarly. So I've got negative x minus 6 on the on the left. So I'm going to add 6 to both sides. The inequality doesn't change, so I have negative x is less than 14. And now I want to multiply by negative 1 on both sides. But when I multiply by a negative on either side of inequality, the inequality flips. So that leaves me with x on the left is greater than negative 14. Let's look at part C. If x is less than or equal to negative 2, I want to find the values of 6 minus 4x. So what I want to do is take this inequality, x less than or equal to negative 2, and manipulate it so that I can get 6 minus 4x on the left-hand side. So I'm going to do that by looking closest to x first and working my way out. So if I look here just at this part, x is multiplied by a negative 4. So I want to multiply by negative 4 on both sides of the inequality here. So I have negative 4x on the left and negative 4 times negative 2 on the right. Negative 4 is negative, so when I multiply on both sides, I'm going to flip my inequality. So this says negative 4x is greater than or equal to 8. And now if I work my way out, this is 6 minus 4x, so which is the same as 6 plus negative 4x, right? So I'm going to add 6 to both sides of this inequality. So I get 6 plus negative 4x is greater than or equal to 14. And 6 plus negative 4x is the same as 6 minus 4x. So 6 minus 4x must be greater than or equal to 14.